Are you ready? 6.3. Here we go. Today we start 6.3. The title for this one is Logarithmic Functions. Y'all, I think these are the coolest. They're puzzles. You'll like them. No, you're going to like them. They're cool. Okay, so here's how this works. If I have something in exponential form, hold on, I can't spell. Exponential form. Hey, focus. It is in the form of y equals a times b to the x. Are you following? Okay. So I might have something that says like 2 to the 5th power is 32. Do y'all know that off the top of your head? 2 to the 5th is 32? Okay, watch. 2 times 2 is?
4.
Times 2 again?
16.
Nope. 8. 2 to the 4th is 16. 2 to the 5th is 32. Everybody can follow that? Okay. What we're learning today is what we call logarithmic form. Logarithmic form. Logarithmic form. I'm going to change this exponential form. Y'all have understood that to be the case for what we've been graphing, but I'm going to rewrite it as b to the a equals c. It's going to make this make a lot more sense.
Yeah, definitely not me writing the b. They change it after I've written it down.
I'm sorry. B to the a equals c. That's logarithmic. B to some exponent equals a constant. Everybody's okay with that? Okay. In that same form, we can write a logarithmic expression. Log base b of c equals a. How many of you are in chemistry right now? Y'all have been learning logarithms.
She's been teaching it.
Yeah.
Okay. Log base b of c equals a. So the way this works is we can write, if I'm using this particular exponential equation, log base 2 of 32 is 5. So it's a way of saying the same thing, but in logarithmic form. These are actually equivalent statements. No. No trig. No, just got words in it.
You plug in moles.
No moles. No. Logarithms.
I'm leaving the class.
You don't have to leave. It's fine. No moles. I don't speak chemistry either. I promise. This is called logarithms. So here's the deal. These are both representing the same information. Okay? Want to focus on a couple of things. This letter in the bottom here is the same number here. Do you see the B is the same B?
Yeah.
Okay. B is in the basement. And I would have you write this. The base is the base.
Why'd you add a J?
The base is the base. That's a T. The base is the base. And what I mean by that is if it's the base on the exponential equation here, it's the base on the logarithmic equation here. So that b in the basement that's raised to a power, that's the base in both places. Are you following? So far, so good. Okay. Now I want to highlight this exponential portion. Do you see this letter A up here floating in exponent land? Do you see that the logarithm equals a? Okay, so when my mom taught this to me 1,000 years ago, the words that she used to teach this were the log is the exponent. The log is the exponent. What that means is the logarithm side equals, the log equals the exponent. So if I was going to rewrite this in exponential form, what would be my exponent?
A.
A. Exactly. Can you see what I'm saying?
Look at me.
Look at you. Okay, here's some other fun
Wait,
facts.
Then how does log equal A?
Just
Wait, log B,
give
C.
it. Just we're gonna get there. Okay, here's another fun fact. We read log base b of x as the log base b of x.
Whoa.
Ah.
What is that?
Log base b of x. So when you see the words or the letters that have a log and then a little b, but down below, and then an x, the words that we say are log base b of x. What?
What are those two lines by log?
That's quotation marks.
Oh.
Like things that we might say. We read it as, and things that you would say out loud.
Use that in math.
Here we are. Okay, so far so good. All right, here's another fun fact. Logarithmic functions are inverses. Logarithmic functions are inverses of exponential functions. So exponentials and logs are inversely related, okay? What does that mean? That means that one undoes the other,
Yeah.
right? We learned this year that if I square something, how do I undo it? Square root it. If something's being multiplied, how do I undo it? Divide. If something's being raised to a power, how do I undo that? You log it. Okay? So this is going to get really cool. Understand that they are inversely related. What that also means is that the domain and range are inverses of each other. Okay? So let's get a recap here on an exponential function. I'm going to graph f of x equals a times b to the x. You've learned these week. This week. Too much talking. They look like this. Have you learned these this week? Right? This is an image of exponential what kind? Is it growth? It's going up, right? It has a horizontal asymptote along the line y equals 0. What's the domain of this exponential function?
Negative infinity, positive infinity.
Perfect. Negative infinity to positive infinity. You did. What's the range of this exponential function? 0 to infinity, right? Bottom to top. And it has a horizontal asymptote at y equals 0. Ain't it? Everybody good with that?
Yeah.
Now let's talk logarithm. I know that they are inversely related. So y equals log base b of x looks like this. It's going to cross, instead of crossing the y-axis, the green one crosses the y-axis at 0, 1, right? Initial value, 0, 1. The purple one's going to cross the x-axis at 1, 0. And it's going to look just like this. Oh. Okay, so what is the domain of this new function? 0 to infinity. Very good. And can you tell that we just flipped the range to get the domain?
Yeah.
What's the range of this new function?
Negative infinity to positive.
Perfect. Negative infinity to positive infinity, because they're inverses. So their domain and range are flip-flopped. Is this one going to have a horizontal asymptote? No, now it's going to have a vertical asymptote. Precisely where? X equals 0 instead of y equals 0. So we basically took everything on the exponential function and we inverted it. Are y'all following that?
That's all it's doing? No.
That's all it's doing. That's all it's doing. It's so cool. Okay, so pretend like I had, this is Gracie style. Mom, pretend that, okay. This is exponential, right?
Yeah.
When I have an inverse function, they flip across the line y equals x. That's the rule for inverses. So if I reflect that sucker right over y equals x, where is it now? Laid out like this.
Yeah.
Can you see it? So this one was exponential, the red, exponential, and the purple, logarithmic. Can you see it? Okay, so now this is what I'm going to be dealing with. We're going to be dealing with a logarithm. One thing I want to tell you is you cannot log a negative number. Write on your paper, those are quotation marks again, I cannot log a negative number. And the reason for that is logarithm's undefined at x equals 0. It doesn't go past that. It doesn't go to the left. I cannot log a negative number. The domain restriction is such that x has to be greater than 0. It goes from 0 to infinity. You with me? Okay, so domain restrictions, they happen on rational asymptotes, can't divide by a 0. Right? On square root functions, what's the domain restriction on that? We cannot square root a negative number. Here, you cannot log a negative number because your log is undefined beyond the point where x equals 0. There's nothing for that function to the left. Cool? Okay. Everybody say, this is cool. No, liars. You're sleeping. It's not cool to you. It's fine. It's cool to me. I'm really excited about this lesson. All right, here's example 1. Okay, all we have to do here is convert. It says write, this is example 1, write the following logarithmic equations in exponential form. Write the logarithms in exponential form. So what they're giving me here is this is part A, log base 6 of the square root of 6 equals 1/2. And we're going to convert that to exponential form. And I need you to remember this. Log base B of C is A. And we want to write it as B to the A equals C.
Wouldn't it be?
Give it a shot.
Wouldn't it be 6 to the power of 1/2?
The square root of 6.
Equals square root of 6. And isn't that true? See? So we've converted it. Now we've written that same information as an exponential. Perfect. So it goes, I always kind of make a little swoopy line. If I'm trying to convert, I'm going to raise that B to the A power. B to the A equals C. Can you see it? Okay, let's try letter B. Letter B says log base 3 of 9 equals 2. So we're going to convert that.
So 2, 3 to the
Yeah, B to the A. So 3 to the A
2
equals 9. And is that true? That's how you can check yourself. Like, actually do the math. Yeah, that works. See, B to the A equals C. Any questions on that? You want to do a couple more? Let's do, this is a try it. What? Here's a try it. Log base 10 of 1 million equals 6. Now rewrite that in exponential form.
6 to the 6.
Hold on. The log equals the exponent. So 10 to the 6th power equals 1,000,000.
I'm not writing all the figures.
Okay, cool. But you can do it, right? You're not wanting to raise 6 to the 10th power. It's got to be b to the a. The base is the base. The log is the exponent. Cool? Okay. One more. Log base 5 of 25. Can anybody do it?
Where's Benedict at? Oh.
Right, second best. Joseph, let's go.
5 to the second is 25. Okay, so we're good with this. Can you understand the puzzle?
Yeah.
5 to the second power equals 25?
This is nothing like a puzzle.
I told y'all this is cool. Okay, whoa. Don't throw things. Easy. Some big old angry mare back there. Some mule. Whoa. Whoa, boss. Are we ready to move on? Yes?
Maybe.
I'm ready. Okay, here we go. Example 2. Example 2.
We did keep doing this.
Convert from exponential form to logarithmic form. Y'all with me? So for A, the exponential says this. 2 to the 3rd is 8. And we want to write it as a logarithm.
Log to the second
Log base 2
times 3
of
8 equals 3.
8 equals 3. So you got to work on the words. Log base 2 of 8 equals 3. They do not know what you mean. So the base is the base. The power is what the log equals. Yeah? Okay, let's try another one. Here's letter B. 5 squared equals 25. We did, but we did it backwards.
Log base 5. Log base 5 out of 25 equals 2.
Of 25 equals 2. Perfect. Rock solid. Log base 5 of 25 is 2. Okay, last one. 10 to the negative 4th power. Now we know what happens when we raise something to a negative 4.
You gotta take it to the bottom.
It goes to the bottom. So this actually comes out as 1 over 10,000 or 1 over 10 to the 4th. Right? We would take it to the bottom. That would equal 1 over 10,000. It becomes a fraction when it's a negative power. Y'all with me on that? We can still convert it though.
It's it'd be log base 10
Of
10,000 of 10,000.
of 1 over 10,000 equals negative 4. Your exponent is what it equals. The base is the base.
You just said I can't log a negative number.
I didn't log a negative number. The log can equal a negative number. Great question. He said, hey, listen. He said, I thought we just said we couldn't log a negative number. So what I'm saying is this number inside the parentheses, the argument cannot be negative. You are correct. It can equal a negative number.
So like the 10, would that be a negative? Like log?
The base? No, the base is not going to be negative either. Your base is going to be greater than 1. Or greater.
They can only equal a negative. So
It can equal a negative.
they can't.
You're correct. Right. C cannot be negative. It's called the argument. The argument will not be negative. Great question. Man, y'all are awesome. All right, so we know how to convert. We can go from log to exponential. We can go from exponential to log. Yeah? Now let's solve it. I think y'all were almost there. This is example 3. And our instructions here say solve. Uh-huh. Okay, so x equals log base 4 of 64. What is x? So here's what you have to think. 4 to what power equals 64?
What did you have? Fourth
8.
root of 64.
Not the fourth root of 64. 4 is the something root of 64. It's not 8. It's too high.
3.
3. 4 cubed is 64. So x must be 3. It's a puzzle. X is 3.
How did you get 3? The calculator says it's 32.
No, 4 times
4 cubed.
That's 4 times 64. The square root of 64.
is 8, but that's not what we're asking. Do the cubed root of 64.
Hey, do that.
It's it's control the button next to the square root button.
3.
3. See?
Oh.
Let's try it. Try this one.
It's 4.
X equals log base 121 of 11.
Yeah. Cubed root of 64 is 4.
Right, that's what we said. 4 to the third power is 64.
I'm still lost.
And we just solved for what power. To what power are we raising 4 so that we get 64? Okay, so this one's going to be 121 to the something power would give us 11. Yeah. So x must be 1/2. What do I raise 121 to in order to give me 11? Not negative 2.
Positive 2.
No, you're thinking, though, it's the half power.
Yeah, I get
It's
that.
not a negative power, but if you square root 121,
Yeah.
you get 11. So what power square roots? The half power.
Yeah.
You're onto it. You're onto it. All right, let's get some more. Let's do this. This is example 4. Y equals log base 3 of 1/27.
Why did it add a y?
Well, we're solving for y this time. So we know that 3 to the y power, if we write this in exponential form, 3 to the y power is 1/27. So what do I raise 3 to so that my answer goes to the bottom? 3, but it's negative. Good. So y equals negative 3. Okay, so listen again. I'm raising 3 to some power, right? 3 squared is 9. 3 cubed is 27. But I need to make it 1/27th, which means my 3 to some power, that power's got to be negative in order that it shows up in the basement. Right? If it had just been 3 to the y equals 9, what's y? 2. If it was 3 to the y equals 27, what's y? 3. But I have 3 to the y equals 1/27th. So the power's got to be negative or it doesn't come out a fraction. Is that better? Okay, let's try one more. Y equals log base 2 of 1/32. Negative 5. Negative 5.
What?
2 to the 5th power is 32.
Oh, yeah.
Right? We did that first. That was the first thing we did today.
Alright, so just think about it, just forget about the 1, think about what it would equal to.
Yes.
And then you add a negative.
Make it negative so that it comes out a fraction. Exactly. Good, Mason. So y equals negative 5. 2 to the what power would give me 1/32. 2 to the negative 5th. Are we sweet? Yes? Everybody understand? Okay. New thing. It's called a common log. I do not know. Yeah, we can get there.
I don't think we have enough time.
Okay, when you don't have a number in the base, it's called a common log. Okay, when you don't have a number in the base. So a common log should look like common logarithm should look like log base 10 of x. But when it's a base 10, we call that the common log. So instead, we just write log x. Have you seen this in chemistry where there's no base? That means you're in common base 10. Is that making sense?
So,
But if we put it in a calculator, it would have to be log 10.
If you put it in a calculator, yeah, because your calculator software at this point opens an automatic base. And you have to put a base. So if there is no base, your automatic base is base 10.
what is it equal? Does it give us that?
Sure, so let's do one. This is example 5. Example 5 says y equals log of 1,000.
Okay, so
So what's y? Not 2.
negative. Wait, no.
If it was log of 100, it would be 2. It's log of 1,000. 10 to what power gives me 1,000?
Oh, instead of 30.
10.
Third.
30.
10 times 10 is 100.
Oh, because 10 times 10.
Times 10 again. Right? So how does this work? There's an invisible 10 here. When I'm in common log, the base is automatically 10. So the way this would read would be 10 to what power y would give me 1,000. That's why y is 3. Okay? Any questions on that? On your calculator, this is example 6. Your calculator wants you to evaluate this log. So let's try it. Put on your calculator log, and it's going to automatically populate a box. But this is log of 321. In the box, because there is no base, you automatically put a 10 and push equals.
Right there under the 10x. Push control. Wait, I put 32, 32.
321? What'd you get, Nico?
2.50651.
So 2.507.
That's what I got.
That's how you do it. So when there is no number, the base is 10.
And that gives me what, my y?
Yep. So this would solve the problem. 10 to the 2.507 is 321. Okay, so sometimes you can't do it in your head. Your calculator can solve it for you. Benedict, maybe. Okay, there's one more. This is called the natural log. Natural logarithm. Y'all remember that number e that we learned? So this is log base e of x. But we don't put log base e. We shorthand it. And we put ln of x. And all that ln stands for is a log in base e.
Where is that?
Next door.
ln what?
Of x. So let's try it. This is example 8. It wants you to do ln of 500. This is called the natural log. The natural log of 500.
6.215.
Y equals. ln.
Look, right there. Next to log. 6.215.
Yep. So the natural log is a logarithm. It's the same as all the other ones that we've learned. But it's a nice little fancy whoopee with an e as the base. So every time e is the base, we use the notation for natural log. It just saves time and it saves keystrokes. Okay. Try natural log of negative 500. See what your calculator says.
Wait, do you log E?
You could. If you did, so Mason's asking, do I do log base E of 500? Mason, if you try that, you'll get the exact same number, 6.215. Because natural log and log base E are the same thing. It's another way of writing it, and it's better. Whoa.
I don't think that's right. I got 0.621.
Did you do a 500?
I did log
calculation.
10,500.
Don't do e to the 10th. Just do e to the
Just
first.
do E and then erase the
How do you
exponent.
put the e in?
Look,
That's why it's so much easier to write natural log.
Look, I think control.
When you did negative 500, what happened? It doesn't work because you can't log a negative number. Right, it's undefined there. That's all I wanted you to see. This is bad. No bueno. Can't log a negative. Good? Y'all, we got through it. That's the whole 6.3. That's all of it, the whole lesson.
Why is the easiest?
Excellent job. Hey, you do have a homework assignment. It is published in Canvas. Get after it.